Convert 9 3/5 to 48/5 before multiplying.
Morning light reaches Fraction Area Cove after a high tide. Sedge, the river otter, is out exploring the shoreline. He's swimming along a lush reed bed. We know this entire bed covers exactly 2/3 of an acre of land. But the morning high tide has flooded the lower edges. Right now, only 3/4 of that area remains above the waterline. We need to find exactly how much land that is. This sand model lays out the problem. To multiply 3/4 by 2/3, we multiply the numerators across the top. 3 times 2 is 6, and the denominators across the bottom. 4 times 3 is 12. That gives us 6/12, which simplifies to 1/2. And since we are tracking physical land, we keep our unit. Exactly 1/2 of an acre remains dry. Whenever you multiply a fraction by a proper fraction, you are calculating a precise, smaller slice of an original amount. Moving downstream, Sedge finds a piece of driftwood caught in the moving current. The entire piece of wood is exactly 1 1/2 yards long. We need to calculate the length of just 2/3 of it. To multiply with a mixed number like 1 1/2, you have to rewrite it as an improper fraction first. The number 1 1/2 becomes the fraction 3/2. Look at the marks carved directly into the wood face. We multiply 2/3 by 3/2. 2 times 3 is 6, and 3 times 2 is 6. 6/6 simplifies to exactly 1 yard. Sedge swims onward, arriving at a rectangular tidal pool framed tightly by straight stone edges. The pool has a length of 2 1/2 feet and a width of 3/5 of a foot. To find the surface area of any rectangle, we multiply length times width. We start by converting that mixed length. 2 1/2 feet rewrites as the improper fraction 5/2. On this sand model, we can trace the calculation. Multiply 5/2 by 3/5 to get 15/10. Dividing by 5, 15/10 simplifies to 3/2, or 1 1/2. Because we multiplied two linear dimensions together, feet by feet, our measurement unit changes. The surface area of the tidal pool is 1 1/2 square feet. The final leg of the journey now takes Sedge deep underwater, diving powerfully into the Long Dent Channel. This entire channel stretches out 9 3/5 miles, and Sedge swims 5/6 of that total route. Before doing the math, consider the logic. Since 5/6 is less than 1, the distance Sedge covers must be less than the full 9 3/5 miles. To find the exact distance, we convert the large mixed number. 9 3/5 rewrites as 48/5. The stone markers map it out. We multiply 5/6 by 48/5. The 5s simplify out, leaving us with 48/6, which reduces to exactly 8 miles. Looking back across the cove, the process holds true. Represent the physical context, convert your mixed numbers, multiply the numerators and denominators, simplify your result, and always keep the correct physical unit. With all the distances finally calculated and the morning tide settling, the cove returns to quiet for the day.
5/6 of 48/5 equals 8 miles.